Okay, so obviously we're going to start on doing the graphs first. You've got the steps up there, and in a nutshell, I kind of already explained it up on the board. So first thing you're going to do is factor to find your two x-intercepts or your two zeros. After that, to find your vertex. That's how you find your vertex right there. Now, write this off to the side. That is off of the standard form. So whenever you see that B and the A, that's where we're getting it from. Okay? Normally that will be right. That will be how the problem is given. Not always, but majority of the time it will be in that standard form. You're going to sketch the graph of the function. You need to pay attention whether or not the inequality has an equal to underneath it, because it will be solid. If it has that equal to underneath it, it will be a dashed line. If it does not. Using the two test points, and you'll see what I mean whenever we do this, but essentially what you're going to do is you're going to pick a test point inside the parabola, and you're going to find a test point outside a parabola. A test point is any point you want it to be, but you'll have two, one inside, one outside. And after you do, you plug that in, and if you get a true statement, okay, you take a point, you plug it in, and it gives you a true statement, you shade in the area that it's at. If you plug that in and you get a false statement, then you would not shade where that's at. Alright, so that's how the test point works. That's one way to shade. I'm going to show you another way. The other way is usually the way I do it. You only have to do one test point, just to kind of make sure that you did it correctly. But I'll show you that whenever we get there. So, going to number 1. So first thing we need to do is factor it. So again, what is the first thing I need to do if I'm going to factor something? Greatest common factor. Does number 1 have a greatest common factor? Yes. I'm going to zoom in more. What is that greatest common factor, Ben? 3x. And then so I'm left with x minus 2. Am I done factoring that? Yes or no? Yes. How do I know that I'm done factoring? There are no more exponents. Okay, that's what factoring is breaking it down as much as possible. So now, each one of those factors are going to give me my two zeros, or my two x-intercepts. So what are those two x-intercepts on this? If I set each factor equal to 0, what two numbers is it going to give me? Josh? Positive 2 and what? Yeah. If I set 3x equals 0, 3x equal to 0, what is x going to be? 0. Alright? Guys, don't let factors that look like this complicate things. That should make it easier. It's not as common, and that's why it throws people off, because they don't see it as much as something like this, where, okay, it's 4 and negative 7. Whenever you have a factor that is not in a set of parentheses, that's out here, the thing that looks like we would probably distribute it, that means one x-intercept is 0. Because you're always going to set it equal to 0, and then 0 divided by it doesn't matter is always going to be 0. So anytime you have something like that, it's 0. So I've got those two x-intercepts, one at 2 and one at 0. Next, we're going to find the vertex. Which again, this is going to be negative b over 2a. Okay, Cooper, what is the b value? Looking at the original equation.
6.
Is there anything in front of 6? No. What's in between 6 and negative 6? Tyler, what is my a value?
3.
Okay, so negative 6 is going to be positive 6. 2 times 3 is positive 6. So the x value for my vertex is 1. And then to get the y value, anytime I have the x value of any coordinate, how do I find the y value? Hunter? If I have the x and I want to find the y,
Plug in the x.
plug 1 in for x and see what it gives you. That's the y that goes with 1. So I've got 3 times 1 squared minus 6 times 1. This math should not be very difficult. 1 squared is 1. 3 times 1 is 3. 6 times 1 is 6. 3 minus 6 is negative 3. So there's my vertex. So I've got my 2 roots. I've got my y-intercept, which is one of the roots. And I've got my vertex. So I can roughly graph that right there. I did have this question yesterday, and it was a valid question. Someone asked me, does this right here, the inequality, does that change how I do any of the actual math to find the parabola, the points that are on the parabola? It does not. It's just like if it was equal to. Okay, so those steps are going to be the same. So let's talk about the test points. If I am ever able to use the point, so to pick the point inside the parabola, if I am ever able to use the point 1, 1, I always use that because the math is extremely easy. Okay? So for one of my test points, I'm going to do 1, 1. For the other test point, I'm going to do, let's do 4, 1. Okay, one inside and one outside. Now, those can be anything. I picked 4, 1 for my outside. I could have picked negative 8, negative 9, because it's outside the parabola. For inside, I could have picked 2, 10. Alright, but usually the smaller numbers, the easier the math is going to be. So I'm going to take the point 1, 1, and I'm going to plug those into the equation. Alright, my x value is going to go in for x. My y value is going to go in for y. And I'm going to see whether it gives me a true or false statement. So I have 1 is less than or equal to 3 times 1 squared minus 6 times 1, which we've actually already done, but we'll go through it again. 1 squared is 1. 3 times 1 is 3. 6 times 1 is 6. And so I'm left with 1 is less than or equal to negative 3. Is that a true or false statement? Is 1 less than or equal to negative 3? No, false statement, correct? Can we all agree that a positive number is bigger than a negative number? Awesome. Then I go back, and now I do the same with 4, 1. So I've got 1 is less than or equal to 3 times 4 squared minus 6 times 4. Alright, 4 squared is going to give me 16. 3 times 16 is 48. Is 1 less than or equal to 24? Is that a true or false statement? True. Was that point inside or outside the parabola? Outside. So I go to the graph. And I shade everything outside the parabola. So I'm going to show you the different way that I shade whenever we get to that point. So first, I need to factor it. Right? I don't have a greatest common factor, but so I just need to do box method. What two factors of 8 add up to -6? What two factors of 8 add up to -6? Do what?
2.
Okay, 4, 2, but does it need to be positive or negative? Negative. So Zach, what are my two x-intercepts on this problem? 2 and 4. So go ahead and graph those. After that, I'm going to find my vertex. So I'm going to do the -b over 2a. Anna, what is the a value, or what is the b value? I'm sorry. So if it's a, x squared, bx, and c? -6. Taryn, what is the a value? So I've got -6, which is +6, 2 times 1, which is 2, which tells me the x value for my vertex is 3. Then I'll go in and plug 3 in for x. Three squared is 9. -6 times 3 is 18. And then I've got +8. And all that comes out to -1. Cameron, done. What is the y-intercept on this one? It's somewhere up in the original equation. +8. So I could graph that, and then I could also graph the point symmetric to it. Alright, so this different way that, and this is normally the way that I would shade on this. Now, the only, what you need to make sure to do, if you end up shading it like this, is, well, let me just explain how I did it, and then I'll talk about that. So, you look at this sign. What, if the sign is greater than or equal to, then I'm going to go to the vertex. I'm going to draw an arrow going up, and that's the area I'm going to shade. It is not always inside the parabola. If this vertex was reflected, If it looked like this, then I would be shading outside the parabola. Okay, so I can't tell you that, okay, it's greater than, it's always going to be inside, or it's always going to be outside. It's whichever area the arrow is pointing to. So, before we go any further, what is wrong with the parabola that we graphed there? Somebody tell me. What does that tell us it should look like? Dashed. Or dotted, however you want to say it. So on that, so just get your eraser. Do what? There's no equal to underneath it. So if you look at example 1, it had whatever it was, less than or equal to. And so it's solid. If it does not have that equal to underneath it, then it's dashed. Okay, so I've got that. I'm going to shade inside. And now I'm going to use the point 3,1 to make sure that I did this correctly. So I'm going to take that and plug it into the equation. I've got 1 is greater than 3 squared minus 6 times 3 plus 8. That would give me 9 minus 18 plus 8. And that gives me 1 is greater than negative 1. Is that a true statement? Yes, that means we shaded correctly.
So what do you, so you put in the point.
I'll be going along, filling it out. I'll try not to get too far ahead so that you can just check your work. Whenever you graph this one, make sure that it is not a solid line. And then the test point, again, if I can ever use the 0.11, I will. Because that makes that math really easy. 1 is greater than negative 6. That tells me I shaded correctly. Alright, turn over to the back. So, quite a few similarities on this. So it says factor the quadratic completely. So very similar to that one. The way we're going to look at a lot of this, the concavity, we actually won't need to know that. Okay. So going down really to the fourth bullet, make sure that you do that. It's very similar to the, the dashed or solid line, but whenever you're on a number line, you're going to use a solid dot if you have the equal to, or you'll have an open dot without the equal to. Okay. Now, whenever we get those 2 points graphed or put on the number line, it's kind of the idea of the test point, but on this, we're only going to use the x value because it's just a number line. So you're just going to pick a number that's in between the two, and then we'll shade accordingly. Okay? So, let's kind of walk through this first one. Before I can factor it, what does the equation have to be? Can I factor something that looks like this? What do I need to do with that 15? Move it to the other side. I've got to set it equal to 0. Okay, and I know there's an inequality up there, but remember, it's just business as usual as far as factoring and all that other stuff. All the inequality tells us is really which way to shade. Okay? So the first thing I'll do is I will subtract 15. So I've got x squared minus 2x minus 15. And now I need to factor that. I have no greatest common factor. So I need to find the factors of negative 15 that add up to 2. What would that be? Factors of negative 15 that add up to negative 2. Flip that, the signs. Yep, negative 5 and 3. Okay, so what two values are those two factors going to give me? Taryn?
5 and negative 3.
5 and negative 3. Okay, now, it's not crucial as far as the shading part of this, but do know that that's not really giving us, whenever we graph it, the actual points, if we were to expand it to a grid, an x and y axis, the actual points that we're finding on here are these two. Okay, because this number line is going to represent y equals 15. Alright, not crucial to know that, but just so you know. So I'm going to go on to the number line. Are these going to be closed or open circles? Closed. Why? Because it has an equal to underneath it. Okay, so I'm going to go to 5. There's a closed circle. I'm going to go to negative 3. Alright, and now I'm going to pick, now follow me here, I'm going to pick a number in between those two. Alright, and kind of similar to the graph. If I can pick 1, I'm going to pick 1. Alright, this one we can. Most of these we will be able to, I think. If that's in between the two dots, then I'm going to use it because it makes the math easy. Alright, once I pick that, I'm going to plug it into the original problem. If it gives me a true statement, then I'm going to shade in between. If it gives me a false statement, then I'm going to shade on the outsides of the circles. Okay, so same kind of idea as the test points on the grid. Just now on a number line. So I'm going to go back up to the original. So I'm going to have 1 squared minus 2 times 1 greater than or equal to 15. All right, I'm just picking that x value of 1. So 1 squared is 1. Negative 2 times 1 is negative 2. Is negative 1 greater than or equal to 15? Is that true or false? False. So am I going to shade in between the dots, Manny, or am I going to shade outside the dots? Outside. Now, you need to be able to write the inequalities again that represent that shaded region. So this one over here would be all the values that are less than or equal to negative 3. This would be all the values that are greater than or equal to 5. Let's look at 6. So what's the first thing I need to do on 6? Do what? Move the 6 over. I've got to set equal to 0. So I've got x squared plus x minus 6 equals 0. What factors of negative 6 add up to positive 1?
Negative 32. Oh, negative 2.
There you go. Cooper, what two x values is that going to give me?
X equals -3. X equals 2.
Alright, so I'll come down to the number line, get all that on there. Hunter, are these going to be open or closed circles?
Open.
Why?
Because the sign, there's no line under the grid. I don't know how to explain it.
There's no equal to.
Yeah.
There you go. Okay. On this, can I use 1 as my test point? Yes, correct? It's in between the 2 points, between the 2 dots. So I'm going to have 1 squared plus 1 is less than 6. 1 squared is 1. 1 plus 1 is 2. 2 less than 6. Is that a true statement? So am I going to shade inside the dots or outside? Inside. And then again, you need to be able to write the statement that represents that. So you'd have negative 3 is less than x is less than 2. Let's go down to 7 and 8. Now I'm going to get you started on 7, then I'm going to let you take over. And 8 is pretty similar because there's one step at the beginning that's a little tricky that we just haven't seen a lot of. So, the very first step is the same. I need to add 8. Now, before you factor something, your a value needs to be positive. So I've got that negative on the x squared. to combat that, all you do is you factor out a negative, just like it's the greatest common factor. Okay? So if I pull out a negative, what's that going to do to all the signs? It's going to flip them. So now you would just factor what is inside the parentheses. Should have factored that to get x minus 4x plus 2, which will give you 4, negative 2.
What I get this point, I plug in there, in here.
Make sure that your dots on this are open because it does not have an equal to. Again, the test point I'm going to use is going to be 1. Alright, I want to make it clear, you do not have to use 1 on this. Okay? I use 1 because it makes it really easy, the math, and I'm not interested in doing a lot of hard work if I don't have to. I'll check yours again. That's what I have up here. On number 8, make sure that you're factoring x squared minus 4x minus 5. You've got that negative at the beginning that you need to pull out again. But you should end up getting on the last one right there.